All right, everyone. It is Christmas night. You can see I got the candle burning back there. I've been cleaning my office, and so I discovered a candle randomly in my office. And since it's Christmas night, it's Boxing Day technically. It's 2:30 in the morning. It's still Christmas night. I decided to light it and have a candlelight programming day of Advent of Coding Day. So the part one, as usual, is not too hard. I'm a little terrified of what part two might be. But part one, basically, you just have to identify, it's going to give you a grid of a text grid. And you are going to have to identify which of the @ symbols has, was it 4 or less? Fewer than 4. So 3 neighbors that are also @ symbols. So we just have to identify all of the ats that have 3 or fewer ats in the 8 squares around them. Whenever you do things like this, you should watch out for going out of bounds. Top row, left column, right column, bottom row are tricky, because if you try just accessing above, and you can go out of bounds and segfault or whatever. So that's a very common mistake to watch out for. So other than that, it shouldn't be too bad. So we'll begin with doing the I/O. I've not copied over the actual input here. So we do that. Then okay, it's not word wrapped. Good, it's not word wrapped. I was worried for a second. All right, and then the actual copy, and this will be inside of demo.txt. And there we go. There. You do a doubly nested for loop. I mean, basically, you're going to need to go across every row and every column. So that's a doubly nested for loop. To traverse a 2D grid, you're going to have, if there's 2 dimensions, there's probably going to be 2 for loops. Unless you want to do some sort of like mapping, like you can map that into a 1D array if you wanted, but I wouldn't. And then once you're inside of that, you're going to do another loop to get the neighbors, and there's different ways you do that. Greedy mountain bridges a little bit. Yeah. Doing these kind of 2D grid traversals is a very common thing you do. So what are we going to use here? Probably not you, probably not you. Just vector. Do vector. Okay, so what we're going to do is make a vector of bools. Well, that vector bool, by the way, is one of the most famously bad things in the C++ language, because it doesn't act like a normal vector. It's kind of under the hood like a bitmap, and it's been a big issue of controversy over the years. And then we could hard code the size, but let's not. Let's do this properly. We can make it a vector chars if we want. Why not? And then we can do a few constants. Const char. Other rolls of paper that we're doing. It's like, call it TP. Why not? Equals @ and then so the @ sign is going to be a roll of paper. I think it's supposed to be wrapping paper, but it's funnier this way. And then the only other thing we care about is the dot symbol here. And so we'll call this one open. And then what we do a vector of strings, honestly. You just make it a vector of strings like this. And just, yeah, okay. Decisions. All right. So what we're going to do is, as always, while true, we're going to parse the input. Everything the same size. It looks like it. So we don't need to check for things being of different sizes. Although, you know, maybe that's what they're doing. Part 2, I don't know. We can kind of assume they're all the same size. So what we can do is actually probably going to be pretty easy. Is we will do this. And we could check to make sure everything's the same size. But I'm not going to. In the code. I just checked manually. So what we can do is say string str equals read line of the file. Again, this is using the read library. And we need to open the file as well. I have string ends. We're going to be reading from the demo file. Demo.txt. Okay. To begin with. So, and then we'll switch it out to the real file later on. And so we're just going to read this. We're going to read a line at a time. It's very nicely one line per row of input. We'll do that. And then if we ever hit the end of the file, we quit out of our loop. Otherwise, we will... and all this, by the way, could be compressed into a much more tighter loop if you really want, but this is fine. And then we're going to say vector, map. Ooh, do I want to call it map? Yeah, fine, whatever. Map is a standard library class. You know, there's unordered map, whatever. Map push back. So I'm going to read one line. If we hit the end of the file, we quit. Otherwise, we add it to the end of the vector. And then we will just double check all of this. So for auto a and map. I'll just double check that this read properly. And hit Hideo Kojima. There's a possibility we might meet him, so you know, I'm doing my homework so I can. Can't really say I've played any of his games. I played the original Metal Gear on the NES, but like Death Stranding games like that just look a little too fetus walking around in a jar of urine, like. But we might meet him, so I have to do my homework. Okay, so part of the game development, you know, thing. Okay, looks like it worked fine. Okay, input's fine. And close down my Japanese homework as well. So now we're just going to loop over each row, each column. So we'll say for int I equals 0, and we can use size t. We want to be technically correct. It's less than. And we call this a row. Why not? Row is 0. Row is less than map.size. Row plus plus. We're going to go down each row of the map, and then we're going to go across each column. YYP, to right, and we're going to CW and hit dot and hit dot. Okay, so this is a standard 2D grid traversal for every row, for every column. So this will touch every point on the map. And if you want to see how we access this, dot row, dot at column. Some people, especially if you're not my student, you would expect to see this using square brackets. So this is how like a lot of people would do it. And if I had to, like you can see they're all the same. If I cared about the running speed, I could do this because I'm guaranteeing that I'm not going out of bounds here. Starting at 0, going less than size, I don't technically need to use .at. But what I tell beginning programmers is always use .at, and if your code's running slow, you can switch it out for square brackets later. It is slower, but you know, our CPUs run billions of times a second. We can print out a 10 by 10 grid. It's fine. There's a far greater threat that you go out of bounds, especially on this assignment, where we're going to be having to check the neighbors. And so if you're on the top row and you try and check the neighbor north, and you don't use .at, use square brackets instead. Square bracket will very happily give you whatever's in memory there that's not part of the array, and be like, here you are. And then your code, you know, just gets segfault. It could work, which is the worst thing. It works properly, and then it goes into the code base. It's checked in, and then 5 years from now, your code starts segfaulting, and nobody knows why. That's all verified code. Yeah, that's why I use .at. I don't trust myself, and I tell my students, you know, computer science students are very optimistic. They're like, I'll get it right the first time. The more experienced computer science people are like, I don't trust myself to do this correctly. You know, I'm going to put in every ounce of double checking and every ounce of safety that I can think of. And then if I need speed, I can, you know, switch it out with a faster version later. So this pattern here, by the way, if you're going to print out a 2D grid, we typically do everything without a inline or space. Yeah, even without a space here. But then at the end of the row, we will do the inline. So that's a common pattern for printing 2D grid. And so you can see here, we are correctly iterating over it. A common mistake that people make is they'll switch the row and the column, you know. And so that's why I wanted to double check that I was going across it correctly. Okay, so now instead of printing it out, all we have to do might want to make a copy of this. Do we need the x's actually written down, or do we just need the count? Because if you change the map, if you change an ampersand to an x, it's not an ampersand anymore, right? So there's a couple of different ways we can do this. We could just do it all in one 2D array and just have our logic handle x's. But I think all we need is the count. So for debugging purposes, I don't. Yeah, okay. I'm gonna leave this in here. Okay. There's a reason. Okay, so we need our count, and count equals 0. Should this be a long? Maybe. I don't trust Advent of Code. They love making really big numbers. Okay, so every time we have a square that has neighbors. Okay, here we come to the heart of the code. So I'm just going to write a function called is fewer than 4. Okay, so that's what we're hunting for. We're hunting for given a row and a column and the map, return true or false if there's fewer than 4 neighbors. Okay, and so I'm going to call this fewer I don't know, open zone. Roses, give me a function name here. TP's accessible. Oh, clear fewer than 4, except I don't want to hard code 4 into the name. Open season. Open, sure, whatever. Okay, open season on TP, sure. Okay, so we're going to take in a I'm actually going to switch these things to integers. Size t is correct because the type coming out of map.size is the size underscore t, which is an unsigned 64-bit number. So I'm going to cast this to a integer. And there's a reason why I'm doing this. And the reason why is anytime you have unsigned arithmetic, unsigned ints are super dangerous if you do subtraction. And I'm going to be subtracting things, and I've been burned way too many times in this. I'm just going to use an integer. It's not likely we're going to have more than 2 billion rows or 2 billion columns. We'll be fine. Gandhi, yeah. But like, we're going to be subtracting 1, right? And so we're going to be at the top row, and we're going to be going up a row. And guess what? 0 minus 1 is not -1. In the unsigned universe, it is max int. So, yeah. I'm just going to use integers, and that's just going to make my life easier. So given a row, given a column, given a vector of strings by reference named map. Do I want this const? Am I going to modify it? Maybe. I'm going to have to think about that. And then I'm going to give it a threshold. So this function will return true if the number of neighboring TP squares is less than threshold. Okay. So it's probably a good function name in there somewhere, like below threshold. I don't know. I give up. Open season it is. And so we're going to return true or false. And so what we need to do now is we are going to check the 8 neighbors. And then if it's out of bounds, we just skip it. Count equals 0. And then every time we find a TP there, we are going to increment the count by 1. And if the count at the end is less than threshold, return true. Okay, so there's a couple different ways you can do north, south, east, west, northeast, northwest, southeast, southwest. You can do a for loop for I equals -1 to +1. There's kind of a fun way of doing it though, which I'm gonna show you. And that is vector of ints calls. Okay, so we're doing a range-based for loop over -1, 0, and +1. So it's just kind of a funny way of doing this. And we have to throw out 0, 0 because that's us, right? So if not I, and not j, we're just going to continue. So if it's our location, we don't count ourselves in the thing. And then all we have to do is say what we could do, and this is actually terrible coding, but it's kind of funny, so I think I might do it, is just go out of bounds, and if it throws an exception, just continue. That's should we do it properly, or should we do it the funny way? What do you think, Roses? What's our all right, proper way it is. Okay, so if our column plus columns is less than 0, or column plus columns is greater than, is it square? I don't know if it's square or not. 6, 7, 8, 9, 10. I think it's square. I'm not going to trust it though, so I'm going to do this. Mapped at 0.size. Okay, so if we are off the left edge or if and that needs to be greater than or equal to, or if we are off the right edge, or row plus rows less than 0, or row plus rows is greater than or equal to. Is it mad because we're doing a signed unsigned comparison? Map dot at 0. Throw some parentheses on here. Map's first row's size should be correct. Yeah, still mad about that. Oh, I, sorry. So J is columns now, row is I. Okay. Column plus J, row plus I. Okay. So if if I is -1, then column -1. If that's less than 0, we continue. So we just throw it away. Yep. And that is how you do 2D bounds checking. You check the left edge, check the right edge, check the top edge, check the bottom edge. It's still underlined, but I think it's fine. Let me just quit, reload. There we go. Okay, so we're now not going to do anything in our calculation. If it's us, we're not going to take anything into our calculation if we're off the top edge, bottom edge, left edge, right edge. So now we just need to do the thing. Here comes the heart of the matter. If map dot at we actually make this simpler, can't we? Okay, so a little simpler. So this is our current location. Y is how far down we are. X is how far to the right we are on the current score we're looking at. And then all we have to do is say if map dot at row is Y dot at X is PP, then count plus plus. That's the heart of the that right there. So everything else is bounds checking. Basically, we're going to go in a loop around the current point. And if we're out of bounds, or if we're me, we just continue. We neglect to take it into consideration, move on. But there we go. And then we just return at the end of the day, the count's less than the threshold. So coming back over to here, all we need to do is say if open season. Okay, row is row. Thank you. Column is column. Map is map. And the threshold is going to be hard-coded to be 4. Okay. So if it's true, then we are going to see out an X. Lowercase x, yes. Okay. Otherwise, I'm going to see out the original thing. See how this goes. Nope, we need n blind still. Okay, let's see how this went. Nope, that one is marked as an X. Oh, because we're not checking to see if there's toilet paper on the spot we're at. So, yes, we need to do that as well. So actually, instead of this, instead of saying just move on here, if we're at 0, 0, if we're at the current spot, if map.at_i.at_j, no, .at, Let's put it back where it was. Just go up here. So if map.at_row.at_column is equal to open, return false. So basically, if we're in an open spot, just we don't do any of that looping stuff. Just move on with our lives. All right, let's see how this works now. Okay, it's looking pretty good. It's like we got a match. So now all we have to do is just output the total count of those X's. And so we already got our count right here. So all we have to do is just throw a curly boy there and a close curly boy there, and just like count plus plus. And at the end of the day, just see out count. And we got 13, which is correct. All right, moment of truth. Let's do this. We're going to swap out demo.text with input.text. And we have 1457. This doesn't work. All right, good, it's the right answer. All right, part 2. All right, so part 2. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, forklifts might be able to access more, which they might also be able to remove. Oh. See, this is what I was talking about, like that, you know, whether or not the thing would be passed in as a const, right? And whether we want the original, like, I don't know if we want to save the original map for some reason, or we just modify this. Okay. So how many total rolls if we just keep iterating over the process? Right, the example above, there's one way you could remove as many rolls as possible using highlighted to indicate that a roll of paper is able to be removed, and using X to indicate that a roll of paper is just removed. So once it's accessed, it can be removed. Do we want to just always remove it? Is there a downside to removing it? Like, does it not count then? Do we count it as a roll if we take it off? If it is, that's very easy. We'll just remove all of them. I think he's just seeing how many are removable. I don't know, because like I think we're going to remove them and then do it again. But if we have to decide whether or not to remove something, that's a very tricky problem. Okay, starting with the examples above, there's one way you could remove as many rolls of paper as possible using highlighted ats to indicate that a roll of paper is about to be removed, and using X to indicate that a roll was just removed. Okay. So they removed all 13. Okay, what I was worried about was like they're going to remove some of them, and you have to figure out some sort of optimization problem. But if you're just going to remove all of the rolls of toilet paper or wrapping paper, I think it's supposed to be, it's not as hard. Okay, then once you do that, then another set's removable, then another set, and we're just going to remove 1, 2, 3, 4, 5, removing 2, removing 1, removing 1, removing 1, until there's nothing left. Okay, that's not as bad as I thought it would be. Because I was like, if you remove it and it doesn't count, then you have to do 2 different branches. Do I remove it? Do I leave it? And which one results in a greater pickup at the end of the day? Here we're just deleting everything that gets marked. So it's not bad at all. I say with confidence, having not coded it yet. Put this back on demo.txt. So what we are going to do is do we delete it as we go along? Is there a downside to that? I don't think there is a downside. Because all it can do by deleting it as you go along is just making more roles removable, right? So we can just delete it as we don't. See, a lot of times when you do these kinds of things, you have to do what's called double buffering. You have to have a copy of the map and a copy of the next iteration of the map. And you run across all of the original map and then write into a new map and then swap them with pointers or other techniques, std swap, and then you do it again. You keep swapping them back and forth. And this one, I think we could just corrupt the map as we go along, which is nice. I say without having done anything. All right, so let's do this. So if we do this, we can just clear this spot. Map dot at row dot at column. Let's go to open. And then when we finish one iteration, we do it again. We keep doing it until we get a count of 0. So while true, so we're going to infinite loop because we don't know how many times this is going to happen. And we are going to equal sign shift 5. Sorry, equal sign shift 5. There we go. Indents everybody between our brackets. And then we're going to need a count. We're going to need a big count, total count. Big total, every total count. 0. Okay. So this will just be total count. And at the end of the day, if count is 0, then we're going to break. So we're going to keep doing this over and over again until we get a count of 0. And we are going to say total count plus equals count. So we're just going to keep subtotaling and adding things up. And I think this will do it. I think. All right, let's find out. Count is 43. The answer is supposed to be 43. Okay. I thought I remembered it as 45. Well, there you go. There's part 2. I'm sure I don't need to run it on the full thing. Yeah, okay. So here, I'm going to go through it slowly. Here we go. Like I said, Roses, this wasn't a hard one. There was a variant of this that I was actually kind of worried about, where you have to like optimize removing it or not removing it. This one, you just delete it as you go along. So as you sweep across, you just pull the toilet paper out. And then if you removed any toilet paper, you do it again. You just keep doing that until there's no toilet paper coming out. Just like in real life. Did you make the previous X's dots? I did, yeah. So what I did was I printed it as an X if it's removed that cycle. So you can see we're going to get the same results, maybe. See, they did a little differently because I'm literally doing it as we go along, and so I'm going to get some earlier X's up here. But you'll see it's kind of ending up with the same pattern here. They're doing the whole. They're doing probably double buffering. They're doing the whole thing, and just the ones that are marked get pulled out. I'm just deleting it as we go along, which is going to open up more things, and so it'll probably do less iterations overall. 1, 2, 3, 4. Mine was in 4 iterations. Theirs is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So theirs was like 11 iterations. Mine was like 4. More efficient my way. Okay, let's see if this works for. You should do the variant. No, because if you try it with and try it without, that's going to be an order 2 to the n complexity, and this maybe for the demo we'd be able to do that, but for the full thing you would have to. You'd have to see if there's some sort of like dynamic programming way of doing that, and this is gonna spam us, but whatever. Okay, 8310, and boom, there it is. Finished faster than 40 minutes this time, even with some discussion of the candle and whatnot. So, yeah, this kind of problem though, where you have a 2D grid and you loop across it and loop over the neighbors is very, very common. And not just like in video games, which you'll always hear me talking about because I program video games, I like video games and teach video game development. But also in like numerical methods and things like that. Like I worked for the UCSD bioengineering department under Andrew McCulloch, who's a wonderful, wonderful guy, very smart guy. And this is, the sort of thing you do with a lot of the numerical methods. Like you have a 2D grid and you have what's called a stencil. So at every point you like grab the values north, south, east, and west and average them or add them together or go 2 out. Photoshop filters work this way, for example. At every point in every pixel in the image, you can do things like average my value with the neighbor's values, and that'll do a little blur. If you want to have a bigger blur, you can have the stencil be bigger and things like that. This is a very common technique. And this right here, where you have that bounds checking, less than 0 and greater than or equal to the size. That's it doesn't look symmetrical, right? But it's because of the half open pattern we use, where if you have 10 elements, it goes from 0 to 9. And so 10 is out of bounds. And so if x is 10, you're out of bounds. And so it's x is less than 0, or you'd say or greater than 9 if you wanted greater than size minus 1. But typically we say if x is less than 0 or x is greater than or equal to 10, if 10 was the size. This code won't work if the thing isn't rectangular. Like if the rows have different lengths, this code won't work. But I skimmed it over. It looked like we were given a rectangle. If I wanted to make my code a little better while I'm doing the input parsing, I could verify that all the rows have the same size. But this works fine. That's probably the only change I'd legitimately make, is just because I don't trust input ever. Somebody can come in and delete a letter out of the let's just show you what happens if somebody does that, right? So if we come in here and vim input.text, and I'm just going to delete the @ on the very first line, so remember that. And if I run it again, segfault, right? So put that back in. There we go. Yeah, if you that's how fragile the code is. And so whenever I do input parsing, it's just kind of a habit. Like it's not necessary for this one because I skimmed it and made sure it was a rectangle. But like for any sort of professional code, I would not make the assumption that somebody isn't going to come in there and fat finger an extra letter or delete a letter or something like that. So what I do is something like equals map dot 0 dot size. for every row, this could be auto. So for every row, if a dot size does not equal row size, then cout error rows in the input are not all the same size. Something like that. And you could also be like, because I think this has to be a square. I mean, I don't think it has to be a square, but the inputs are both squares. So if that was a requirement, I would also say like if map dot size is not equal to row size, error columns must equal rows or something like that, and then quit. So yep. Yeah, so it worked fine. But if we were to come in here and like YYP the last row, run it again, columns must equal rows, take that out and pull that ampersand off again. Rows are not all the same size, and so I like to add a little bit of bulletproofing, I guess you'd call it, vetting your input, never trusting yourself, never trusting other people, especially for input. Like, there's just so many different things. Like, you might pass in the wrong file, because like right now the file is hard coded, right? But like oftentimes that's going to be a parameter, and somebody types the wrong parameter in, and it's not a, they pass in Hamlet, and you try to make sense of it, and your code just seg faults. And I don't like my code seg faulting. It's kind of a, matter of pride for me, not having code that just crashes. And so, when I'm looking at my code, I'm looking at things like this, and I could replace that 0, but like I said, there's this assumption that it's a square or it's a rectangle, and so they're all the same size. And so because that invariant I'm working with here, I'm going to just verify in my input that everything's the same size. Could just that's fine. I'm just going to ensure that this is a square, and then I don't have to worry about anything else. And I made this a const, so it can't change. I guess if my code did like a pushback or something like that, or I changed the length of one of the rows, then I could seg fault or pop back. Nah. Yeah, it reminded me of Wiki taking negative donations because they don't parse input. Yeah, it's just one of those things. Like, especially in input, like my code, like I know my code isn't pushing or popping to individual rows. That's not something I'm not super concerned about. But for input, like you're just handing me a text file, and I'm just gonna assume it's a square of just, I could be getting things that are not these two things. Also, I should probably be checking for that. So if any of the symbols are not one of these two things, then I should probably die or something. As it is, my code will handle it because it only looks at the TP symbol, really, for the neighborhood calculation. So it's not going to crash or anything. But if it mattered, I'd also vet that all of the symbols in the map are symbols that I'm aware of, especially when you are, like you've got like, something more serious than this. And, if you got something like this where there's only like a few different values, I would use an enum instead. And that would look like this. like that, and then changing the underlying type of an enum. What's the syntax for that? Enum underlying type plus. You put a char in there somewhere. Yeah. Come on. Where's the syntax? Colon unsigned char. That's for the enum class, though. Not for enum class. Type. Oh, it's just colon type. Okay, cool. There. Now it's the same thing. And then if you're going to have more options, you just add the different tile options to here. And then you can, every time you read a letter, you can switch on it. And if it's not one of these things in the enum, then you can die, stuff like that. I'm not going to do it. The code's fine. I'm just kind of saying, like, kind of philosophically. Input in particular, I just really like examine very closely. Me breaking things, like me saying like map dot at 0 dot pushback. This would pop back actually. This will cause a set fault, right? So I'm not as concerned about that. That's me to me, my code to my code. I probably, if this was really mission, critical, I would verify that these things can't change size. It's actually something like I might even build my own class for it, like a vector class that can't. I'd build a wrapper around it, so I would remove essentially pop back and push back and things like that, because this thing should not change size. It's a square, and push back and pop back on these things would, like you see here, cause a seg fault. And so I'd probably make my own wrapper around the vector class just to disable things like that can cause, crashes like this. But I'm less concerned when it's me writing code that'll break my code, because I'll just not write that code. For a really large code base, though, you can't afford. You can't guarantee that. If you have 100 people working on the project, you can't guarantee nobody's gonna ever not call pushback at some point. So you'd want to enforce that a little bit more rigorously. But mostly, it's just the input section that I will just sit there and get out a magnifying glass and stare at it and be like, that was an extra 10 minutes of coding philosophy. But the was it like 35 minutes to solve it, something like that? Not bad. This was not a bad one today. So heck yeah, Wolf. Thank you for coming out, and we'll do this again some other time. Peace.